A pleasant day to you, icons and lady icons. Welcome to the fifth module of our discussion on the subject special topics in natural science. And in this module, we are going to discuss everything about liquids. There are actually different properties that are present among liquids, and those are the following. Liquids have definite volume but no definite shape. Instead, they take up the shape of the container in which they are simply being poured. Liquids are also denser than gases, but both liquids and gases are considered to be as fluids because both of these materials can technically flow in different mediums. For liquids, we can observe that it is actually flowing whenever we are opening our faucet, while in the case of the gases, just like on the air that we breathe, just like the breezes that you can observe during the morning or in the evening, that wind is actually blowing in different direction. Also, you can actually observe the presence of liquids and gases on typhoons and thunderstorms. Whenever there is the presence of gust of wind, you can actually observe that the air is flowing in different directions. So if you're going to consider Module 4 and Module 5, there are actually similarities and differences that are present among these different states of matter. In this video discussion, we are going to focus on the concept of liquids that is known as the presence of solutions. Solutions, it is actually consisting of a solute and a solvent. A solute is the substance dissolved in the solution and is usually present in smaller amounts, while the solvent is the dissolving medium. Now, whenever we are talking about different types of solutions, the most common example of a solution is seawater. Okay? In the case of seawater, it is actually possessing the solute, which is salt, and the solvent, which is the water itself. And if you're going to combine salt and the water, it will now create salt water or the brine solution, which is salty water. Some properties that are present on the solute will be incorporated now on the solvent, in which once they mix with each other, they will now create the different properties that are present in these solutions. In this module, and in this particular video presentation, I'm just going to focus on the computation that is related to the concept of the concentration of solutions. In the case of the concept of concentration, we can actually determine the concentration that is present on a solution by means of the following. The first one, percent by mass, which is determined in which it determines the amount of mass of solute compared with the mass of the whole solution. And the other one, there's also the presence of percent by volume. Percent by volume, it is now the one that determines the amount of volume of the solute compared with the volume of the whole solution. Then, the third one, when it comes to the concentration of solution, we are going to consider here molarity, which is the number of moles per liter of solution. And lastly, molality, which is now the number of moles per kilogram of solvent. So now, let's start with the discussion of the percent by mass. It determines the amount of the mass of solute compared with the mass of the whole solution. So if you're going to consider the formula that we are going to use for percent by mass, it would be equivalent to percent of mass is equivalent to mass of solute over mass of solution times 100. The example that we have here is on page number 5 of our module. If 30.5 grams of sugar is dissolved in enough water to make 200 grams of solution, what is the percent by mass of the sugar in the solution? So once again, we are going to use the GRESA method in answering this problem. Let's simply start with the given. In this particular problem, it mentions here that the mass of your solute is equivalent to 30.5 grams, while the mass of the solution, it is now equivalent to 200 grams. Then our required, it is percent by mass. Then our equation, percent by mass is equivalent to mass of the solute over the mass of the solution times 100. Okay? Then, the next one, we're going to consider here our solution in which the actual solution, and not the solution that we are simply pertaining in this particular discussion, the solution in GRESA. Okay? Now, percent by mass is equivalent to the mass of solute, which is equivalent to 30.5 grams over the mass of the solution, which is 200 grams. Then we're going to multiply this with 100, in which we are going to arrive with the answer for percent by mass. For this particular problem, it is now equivalent to 15.25%. Okay, so once again, whenever we are pertaining to the concept of percent by mass, it is now the relationship between the mass of the solute with the mass of the solvent. Okay, once again, from the term itself, percent by mass. Then after percent by mass, let's now consider here percent by volume. Now, in the case of percent by volume, the formula now that we are going to use, since it would be equivalent to percent by volume, it is now the relationship between the volume of the solute over the volume of the solution. Then, since we are talking about percent by volume and percent by mass, you are still going to multiply it by 100. 100 will still be your multiplier. Okay? So this would be the formula that we are going to use for this particular problem. Okay? Now, let's consider the next problem that is also present on page number 5 of our module. And let's adapt the GRESA method once again. You created your own dip for the barbecue you are cooking by mixing 55 ml of calamansi juice with 125 milliliters of soy sauce. What is the percent by volume of calamansi in this solution? Okay? When it comes to the percent by volume, we are not going to convert here from milliliters to liters since the values are the same. Okay? We are just going to convert if the values or if the units for the volume or for the mass is not the same. Okay? Now, for the given, according to this problem, the volume of the solute, and our solute here is the presence of calamansi juice, okay, which is now equivalent to 55 ml. And it is now mixed with soy sauce, in which they will now create the solution. So, in the case of the soy sauce, it is now equivalent to your solvent. Okay? And the volume of the soy sauce, it is equivalent to 125 milliliters. Okay? So, based on the given, there is no definite volume for the solution. So, what we are going to do here is to add the values of the volume of the solute and the volume of the solvent for us to get the volume of the solution. Because remember, solution is the combination of solute and solvent. For you to get the volume of the solution, you need to add the volume of the solute and the volume of the solvent. Okay? Then, now, the volume of the solution, it is equivalent to 180 milliliters. In which, for the required, we are looking for the percent by volume. Then, our equation, percent by volume is equivalent to volume of solute over volume of solution times 100. Okay, still this would be the formula that we are going to use. Then for the solution, percent by volume is equivalent to the volume of solute, which is equivalent to 55 milliliters over volume of the solution, which is 180 milliliters times 100. Okay, so in our solution, we are not going to use the volume of the solvent since we are not looking for the volume of the solvent, but rather we are needing the volume of the solute and the volume of the solution. And it will now give us the answer, which is equivalent to 30.56%. Okay? So this would be our answer when it comes to this problem. Okay, once again, when it comes to percent by volume, we are considering here the volume of the solute and the volume of the solution. Okay, once again, it would be case-to-case basis. Read the problem carefully, okay? Since we are looking for the percent by volume of the calamansi, your final answer should be related to the calamansi. But if we are looking for the final answer or the answer that is related to the amount of soy sauce, it would be the other way around. Okay, we are now going to use the value of the soy sauce as our numerator. Okay, so that would be the case whenever we are talking about percent by volume. Always analyze the problem that will simply be given to you. Before we proceed with the discussion regarding molarity and molality, you need to utilize the number of moles present in the given substances. Now, how are we going to get the number of moles in the substances? If you can still recall, probably on your Science 9, you already discussed this on your chemistry class on how you are actually going to get the number of moles that is present in a certain type of material. Okay? And I'm just going to guide you on how you're actually going to do this once again. So for instance, how many moles are present in 15 grams of salt if it has a molar mass of 58.44 grams per mole? Okay? For us to get the number of moles that is present in this certain type of materials, these are actually the things that we are going to do. So once again, based on this particular problem, we have here the given, which is the mass of the salt, which is equivalent to 15 grams. Then the next one, the molar mass of salt, it is now equivalent to 58.44 grams per mole. Okay, so on your subject, physical sciences, probably on the next semester, this would be discussed to you on how you're actually going to gather and get the number of moles that is present in these certain types of materials. I'm just giving you a hint on how you're actually going to apply this when it comes to the solutions, since this is a part of our discussion in natural science. Then, our required, we are looking for the number of moles or the small letter n. Then for our equation, for us to get this, the number of moles, it is now equivalent to mass over molar mass. Okay, so this would be the formula that we are going to use. Then for the solution, the number of moles is equivalent to the mass, which is equivalent to 15 grams, over the value of the molar mass, which is 58.44 grams per mole, which will give us the answer of 0.257 moles. Okay, since we are going to cancel the grams, then the unit that will remain in this certain type of equation would be moles. In the case of molarity, it is the number of moles of solute per liter of solvent. So remember that the unit that we are going to use here for the volume will always be liter. And for us to get the molarity, this would be the equation or the formula that we are going to use. Molarity is represented by capital letter M. Okay, capital letter M, it is now equivalent to the mass of the solute over volume of the solution. Okay, so for us to get molarity, this would be the formula that we are going to utilize. Molarity is equivalent to the mass of solute over volume of solution. Okay, so now let's simply consider the problem that is present here. Determine the molar concentration of a solution that contains 25 grams of potassium hydroxide in 250 milliliters of solution. If the molar mass of potassium hydroxide is equivalent to 56 grams per mole. Okay, so now when it comes to molarity, once again, we're going to utilize now the Gressa method. Let's consider first the volume of the solution. According to this problem, the volume of the solution is equivalent to 250 ml. But once again, if you can still recall what I told you earlier, it would be equivalent to liters. The unit that we are going to use for molarity, it would be liters. Okay, so we are going to convert this from 250 ml. We are now going to have 0.25 liters. Okay, if you're going to convert 250 ml to liters, you're going to arrive with 0.25 liters. The next thing that we are looking for is now the moles of solute. For us to get the moles of solute, what should we do? So once again, the formula that we are going to use for this part, it is now equivalent to mass over molar mass. Okay? And when it comes to the mass that is present in this particular problem, it is equivalent to 25 grams, while the molar mass, it is now equivalent to 56 grams per mole, in which we're going to arrive with the number of moles that is present on potassium hydroxide, which is equivalent to 0.446 moles. Okay, so this is the number of moles that we are going to utilize in this particular problem. So now, let's consider this value. Required, we are looking for the molarity. Our equation, molarity, it is equivalent to the moles of solute over volume of solution. Then for our solution, we have here the value of the moles that is present on the solute, which is 0.446 moles over the volume of the solution, which is now equivalent to 0.25 liters, in which we're going to arrive with the answer that the molarity of this solution is equivalent now to 1.784 molars or mole per liter. If molarity is represented by capital letter M, in the case of molality, it's now represented by small letter m, or the molar concentration. If molarity is equivalent to molar concentration, molality is now equivalent to molar concentration, in which molality, it is defined as the number of moles of solute per kilogram of the solution, in which the formula that we are going to use here is equivalent to the moles of the solute over mass of the solvent. Okay, so this would be the formula that we are actually going to use when it comes to this. In determining molality, a solution is prepared by mixing 1 gram of ethanol with 100 grams of water. Then the molar mass of ethanol, it is equivalent to 46.07 grams per mole. How are we going to get the molar concentration of this solution? Okay, let's start once again with our given. Our given, it is stated here that the mass of the solvent, it is now equivalent to 100 grams. Once again, what would be the unit that we are going to use here? The unit that we are going to use, it is equivalent to kilograms. So we are going to convert 100 grams to kilograms, which is equivalent to 0.1 kilograms. What would now be the number of moles that is present on the solute? Okay? So once again, we are going to utilize the formula that is equivalent to mass over molar mass, which will give us the value. The mass that is present in ethanol, it is 1 gram in the solution over its molar mass, which is 46.07 grams per mole, in which we're going to arrive with the answer that is 0.0217 moles. As you can observe, we're going to utilize 2 to 3 significant figures when it comes to our number of moles. Okay, so always remember that rule. You are not going to write everything that is present on your calculator. Only 2 to 3 significant figures. Let's proceed with the required and the equation. For the required, we are looking for the molality or small letter m. Then for our equation, molality is now equivalent to the moles of solute over mass of the solvent. For our solution, molality is equivalent to 0.0217 moles over the presence of the mass of the solvent in kilograms, such as 0.1 kilograms, in which we're going to arrive with the answer. The molar concentration of this solution is equivalent to 2.17 molal or moles per kilogram. Okay, so this would now be the molality that is present in this concentration. Now, why is molality and molarity very significant? As you can observe here on the Science, Technology, and Society corner, whenever there is the presence of food preservation, we're actually considering here now the concentration that is present among those different types of solutions. If the amount of the solute is too much for that cell to handle, it might die, or in some cases, it can be preserved. Okay? And whenever we're talking about food preservation, is now lengthening the process of its consumability. Okay? For it to be consumed in the future, we need to preserve every single one of them. So once again, whenever we're talking about the different relationships of the different concentrations, we are considering here the following: the percent by mass, the percent by volume, molarity, and molality. So this is the end of my discussion. So do not forget to answer the practice mix permanent, and do not forget to answer the worksheet that is present on the last page of your module. All of which will be discussed once again to every single one of you when we already had the chance to have your problem set. Okay, so good luck when it comes to your problem set that will be scheduled on November 19 and November 26. Okay, so that's all for the meantime, and thank you for listening.